Look, it's good to see everyone. I hope everyone had a good weekend. There's a bit of snow around. A few of the blokes here have been snowboarding, so and there's no serious damage done, so that's good. Look, just a little bit of general notification. Okay. Look, I'm just looking through some of the calcs that you've been, your quizzes. I'm looking through some of your quizzes, and there's only about 70 to 80 students that are completing it. Okay. And most of those people that have completed are pretty good. But that means that there's still about another 35 or 40 that haven't done any of the quizzes. As I said, each quiz that I've put up, there seems to be about 70 to 80 people are doing it. And there's, say, another 30 or 40 that aren't doing it. So when you come to your prac day, you're going to struggle. Okay. So it's up to you. And like I said, most of them are pretty good. Some of you that are struggling with some of the calcs, you need to go back to the film or to the example of the sheet that you're doing and just have a look. Or alternatively, just come in and we'll see if we can just sort you out, because a lot of the time it is only something that's fairly minor. Okay. Everyone hits the wrong key. I mean, I'm guilty of hitting the wrong key occasionally. You get so muzzy with numbers and that you just hit the wrong key. So it's not that sort of person that we're after to try and help. It's the person that's just having a little bit of difficulty. Okay. The prac night tomorrow night. Now I can only talk for Wollongong. It's at J Block. We'll start at 5 o'clock. We'll start a little bit earlier, just for someone, if you're working in the area. It doesn't matter to me whether I'm in the office or out in the workshop. So I'll be there from 5 o'clock till 8:30. I would advise anyone to bring their own equipment, whether it's just for the prac night or whether it's on the field day itself. If you've got your own optical level, laser level, bring it in. All right. Your equipment is probably far superior to TAFE's. And I'm not saying TAFE's isn't functional, but TAFE's equipment is used by hundreds of students who don't own the equipment, so they don't take as much care as they possibly should or could. Okay, so that's tomorrow night. What you need to bring tomorrow night, you need to bring a pencil or pen, you need to bring a tape, and you need to bring a calculator. There's no use turning up without a pencil or pen and a calculator and a tape, because you won't be able to do the booking sheets. I'll have booking sheets there, so everyone can complete their booking sheets. We'll be doing a 2-peg test, or you'll be doing a 2-peg test, doing a closed traverse and some inverted readings. Okay, but it's also to get you used to setting the equipment up. Okay, if you can't set it up, you won't be able to complete the field day. Okay, so you've got to know how to set it up. All right, tonight it's good news. There's no booking sheets. Okay, there's no small calculations. There are some calculations. Tonight is more of a slopes, grades, angles, ratios, percentages. It still has some difficulties as we move through it, the last little section, and there's probably 4 or 5 quizzes, and the last one being probably the worst one, but it won't be too bad. Look, just with how steep is that slope? Look, I'll just open this one up. It's not playing the game yet. There we go, it's over here. All right, it's over here. All right, now this is basically what we'll be looking at today. On your field day, you've actually got to calculate the slope, the gradient of a drainage pipe. You've got 2 pits. We've got a pit, say pit A, and then 30, 35 metres away, there's another pit, pit B. So you take the levels of the ground, you take the levels of the pipe at both ends, and you actually have to calculate the slope of the pipe. Okay. Now, okay, if you look at this sort of does go into contours as well. You know, it's all linked because it's all a slope, or, you know, like this says, how steep is steep, or what is a grade? And this just goes through here. You know, steep means either rising or falling sharply, or unreasonable or excessive. It's concerned with rising or falling sharply, and it doesn't have to be rising or falling sharply. It can just be a really gradual one as well. Steepness, how does that affect us? Well, probably most of the time it would be in our driveway. You know, most people would be affected by steepness in their driveway, or possibly if you're snowboarding down the side of a hill. Okay, that would be one of the things you'd be interested in, how steep that hill is. But okay, this is probably the most common, where your car bottoms out. Okay, it can happen at that point there. It can also happen if this goes down. I've got a couple of photos of these things as well. So we need to be able to just calculate changes in grade. So we've got 3 changes in grade there, slope, 3 changes in slope, 3 changes in slope. And we would also use it for possibly drainage as well. But, you know, the side of the hill, you know, this is important too. This is the driveway. There is a formula, I'm sure you could get on the internet through Google, and it would tell you what are the slopes that you would bottom out on if your car, if you knew the minimum clearance between the bottom of the car and the ground. Okay, so how far the wheel keeps the body of the car off the ground. Okay, so the 3 ways we can calculate a slope: we can have an angle, and the important things that we need to know are the height and the depth to be able to calculate the angle. We need to calculate a slope, we can use a ratio, and the same thing, we need the same thing, that just the height and the depth, okay, and then a percentage. So to calculate what percentage of slope there is, or what percentage the slope is, we need the height and the depth. Okay, and yet all those, and at the bottom there you can see all the diagrams are exactly the same. We're just calling that slope 3 different things. All right, so that's what we're looking at tonight, those 3 things. I'll just open that one up. Okay, now the first thing that we'll look at angles. I'll just show that, show the next one. Okay, and it's slopes, grades and angles. Okay, so we'll just have a look at this. Okay, so unfortunately I can't make it any bigger. But okay, slopes, grades and angles, all the same thing. A driveway, the bottoming out of a car. Sewer lines, okay, you might have bought a block of land, you might be building a house for someone. You know, how much fall, slope, grade is there to the point of connection. Okay, every block of land, every house has a point of connection somewhere. So if most subdivisions now are pretty flat, so it'd be handy to know how deep your sewer connection is and how deep you can actually go with your sewer. Because once you get below a minimum slope, you've got to have, it's not a reflux valve, but it's something like that stops the sewer from backing back. But that's your last resort to be that flat. So yeah, knowing a slope, a grade or an angle is really important. Also too, you've got to put stormwater around your house as well. You know, a lot of the time the plumber does it. Sometimes if you work for a small builder, you might be putting the stormwater lines around. And what would happen is sometimes those stormwater lines go to the street. You get direct fall to the street. Sometimes there's an easement down the side of your block where you might get into the stormwater easement. But it's always handy to know if you can get enough fall to get the water out to the street. Okay, the other thing is to be able to calculate a change in slope. So tonight we'll be calculating a change in slope. You know, so we'd be going from point A to point B, and that could be something like following. You might need to put a stormwater line in or a sewer line in a block of land, and it needs to change slope. So we'll be able to calculate those slopes. Thing is, you may not remember how to do it because it's a whole lot to remember, but if you have a reference point, you know that it's possible to do, you'll be able to find it. This is this photo here is an example of bottoming out. I mean, I'd get a different car because if he went over a speed hump, he'd be in trouble. Okay, so I'd be looking at a new car in that instance. But if you look here, because of the size or because of these cars having a small amount of clearance from the body of the car to the ground, there is a greater occurrence of bottoming out. So that there's a big market there. You can see here people put these rubber mats, these rubber like small packers in there, so that you can actually get in and out of your garage without ripping the exhaust out. So yeah, look, that's just some of the things that lift it. Yeah, actually you could, every time you got out of the car, you got your car out of the garage, you could lift it. You wouldn't need to go to the gym then. So, all right, so that's just a couple of the reasons, or a couple of the reasons why we might need to be able to work it out. Now, calculating angles from heights and lengths. We'll show that. Okay, this is just an example. So, okay, all you do with this, and I got this computer calculator. I got the calculator off the computer here, and I was having a little play with it before. But when I came to class, it had a different format, but I just managed to sort it out in time. So, okay, and look, everyone's calculator will be slightly different. So the reason I got this calculator here was because on mine, I've got a Casio, I think, and I press Shift-Tan when I want to, when I've got a degree, because we're going to end up with a decimal point here. So we want to convert this decimal point to degrees. So on this, what we would do, our answer here is 10 divided by 100, because that's the height. That's the height divided by the length, and that's how we calculate this angle, height divided by length. So we've got 0.1. So what we do here, we actually go tan minus 1, and then that gives us the 5.711 degrees. I don't know how to get rid of these other 20 numbers, but this would be 5.711 degrees, okay? So all we did, I'll just go back again, and as I said, this isn't a bad calculator to use. So if we had 0.1, we went tan minus 1 is 5.71 degrees. Okay, easy as that. So that's even easier than your phone. Okay, anyone that's got a phone and uses that for a calculator, it's taking you a lot longer than using this, but you can still use it. With your phones, I think if you turn them sideways, it'll give you the scientific calculator. All right, so I'll put that aside. So that's pretty easy to do that one. There's an example there on how to calculate your angles. We go down here, we'll have a look at ratios is the next one we'll have a look at. I'm just going to go through all these exercises, and then I'll open the quizzes up. I'll open your activities up after that. So now we're going to go to ratios. There's an example here of a ratio. All right, so if we look at that, it's the same. What this is, it's got the formula there. So to get the ratio, it's the length divided by the height. Okay, so all these calculations that you're going to do tonight, if you're not familiar with how to do them, are there for you. Okay, so with ratios, just say for instance this, we've got a height of 2 meters, a length of 10 metres. So we're going to go 10 divided by 2 equals 5. Therefore, the ratio is 1 in 5. So every time you do this calc, you'll be getting a ratio of 1 in 5, 1 in 4.12, 1 in 3.11. It'll be the second number will be the one that the first number will always be 1. The second number will always be the ratio. All right. So I'll get rid of that. Minute. Now we go to grades as percentages. Okay, we have a look at grades as percentages. All right. So what have we got here? Oh no, that's ratios, grades as percentages. Okay, so let's look at this grades as percentages. Okay, we'll come back to that. I'll just make that as big as I can. So, okay, with percentages, it's height divided by length times 100 equals the percentage. So, okay, in this we've got 12 divided by 80 times 100. So all we do here is 12 divided by 80. And okay, I always put an equal sign there. Equals 0.15 times 100. And that's our percentage, 15% slope. Okay. If you put that whole calculation in, okay, and I'll do it for you. We clear this. If I put in 12 divided by 80 times 100, okay, it made a liar of me. Okay, but I can tell you that it doesn't always work like that. You have to put an equal sign in or use brackets. Okay, so 12 divided by 80, that was probably just one of the exceptions that it worked out being the right answer. Okay, so ratios is done. Now, we close that. Now, we go into chainages. Now, what we'll do with chainages or chainage, we'll just have a, does anyone know what a chainage is? Well, I'm about to show you. Okay, the term, and I'm not sure, that's probably pretty hard for you to see, but the term chainage is used in surveying to refer to a distance measured in metres along an imaginary line, such as the centre line of a road or a railway. Okay, so okay, that says there a road or a railway, but what we could do, we could actually use it for our pipes, which is what we'll be doing on our field day. Okay, so that's why we actually need to know this one. Now, this one's just a little bit more, there's a little bit more in it. So if we have a look at what it is here, okay, so what this is, let's just say we are coming from this side here. Let's insert. We're coming from this side here, okay, and this is where our instrument's set up over here, and we're taking readings coming here. So what happens here at chainage 1, this is 97.26 metres from where we're taking the readings from. Okay, so that distance is 97.26 meters from where we're taking the readings from. For another, okay, there's a change in height here. So that's called chainage 2. Okay, chainage 2, the distance is 145.73 meters. Okay, so if we looked at that, if the distance between these 2 points would be 145.73 minus our 97.26, and that would give us the distance between those 2 points. Now what happens, that's a positive, that's a slope going up the hill, but then what happens when you note these things on a plan, you've got to have something for when you go downhill. So, okay, they've gone up, which would be a positive, and say it was 15 degrees or whatever, and then you go downhill, and what you would have, you might have -8 degrees, so that you know that the slope has gone up to chainage 1 and then it goes down to chainage 2. All right, so this is the formula for to calculate the percentage and the angle. Okay, so the distance equals chainage 1 minus, or chainage 2 minus chainage 1. All you really need here is the difference in the distance, okay? And that gives you the distance. Then you need the height. So it's chainage 1 is, the RL is 87.11, and the RL here is 75.865. So you take those away and you end up with a height of, and then what happens to get the grade, it is the height divided by the distance times 100 equals your percentage. Okay. Then what happens with an angle, and this is for chainage 2 to 3. Okay, so we've done percentage on chainage 1 to 2, and we're going to do an angle on chainage 2 to 3. So the distance, we don't need to know our first distance back here. To get the distance between these 2 chainage points, it's 180.635 minus 145.73. Okay, and that gives us our distance. Okay, chainage 1 minus chainage 2. At this stage, it doesn't matter if it's a negative number, the distance, because it's just the distance. Okay, then when we go to the height, we have chainage 3, take away chainage 2. Okay, because that's the one that we're going to, and this is the one we're going back to. So we use our RL, the furthest RL. So this would be 81.52 minus 87.11, and that would give us a negative answer. But okay, if we go back to the angle, it's the same formula as we had before. It's height divided by distance is the answer, and then we go through that process. Depends on your calculator. If you use I think it's a Casio, it's press shift tan and then your answer, and then that gives you the angle. Okay, so in that, this is just the example of those two. Chainage 1 to chainage 2 was that distance that we had there, 145.730, 97.260, gives us that answer there. Our height was 87.11 minus our 75.865 over here. Okay, so that gives us our height there. So then we go back to our formula for percentage. It's height divided by distance times 100. So it's 11.25 divided by our 48.47 and times 100. And that's how we get our percentage, 23.19%. Okay. Our chainage 2 to chainage 3, the percentage, and this is just our example. So I'll just get this calculator. As I said, I thought I'd try the TAFE, the computer calculator. So okay, on this, if we had minus 5.59 divided by 34.905, 34.905, equals, okay, then times 100. Well, that didn't work. We'll go back and do that one again. So it was minus 5.590 divided by 34.905 equals times 100. Okay, 16 degrees. What it is, it's minus 16.01 degrees. Okay, now it depends what calculator you have. Every calculator will be slightly different, yeah, so you do, on the calculator that I have in my bag, it was Shift Tan. That's what I had to do, and then I put the number in. Okay, I thought this was easier just to show you with this scientific calculator, and that's pretty easy to use. Okay, so so we've done the percentage. Okay, we could do the angle. I'll just go through that angle. The angle is chainage 1 to chainage 2. We've already got our totals there, and our formula is height divided by distance. So we've got a height of 11.245 divided by our distance there, 48.47. That equals our 0.232, and depending on your calculator, you can press Shift Tan. That's not a minus figure. I'll just delete that. That should be that. Shift Tan 0.232, and you'll get 13.06 degrees. Okay, is everyone pretty? Everyone seems pretty happy with that. The best way to actually find out is to actually start doing it. Now, like I said, everyone will probably have a similar calculator, but it might have a small trick to it. As I said, it mightn't be Shift Tan, but it'll be something similar to that. So don't save. Okay, so what you do then, we've got we've got one last thing just to look at. We're not going to do these contours and excavate to an RL yet. I think this, I'll just have a look at this quiz question. Hopefully the answer's not there. Okay. Now I'll just blow it up a little bit. Okay. Okay. What it is, this is more applicable to what you'll be doing on site. So this is a street with 3 blocks of different sizes. You've got to do the calculations to work out what the diagonals are, what these missing sides are. Okay, so you've got to actually do the calculations on 3 blocks. It's the same formulas, you've just got to be able to work them out, and there's a whole lot of choices there for you to make. All right, so that's the last quiz, and that's the last activity. There's a fair bit of work for some of you, and some of you will really cruise, and this will be a piece of cake for you, and other ones will take a little bit longer. All right, so that's virtually it. That is it for the learning materials. I'll just open them all up. As I said, you use your calculator or whatever you want to use. You can use the one on the computer. Okay, that's where I want to be. And as I said, I'll start opening up. I'll open up one of the top quizzes for you to get a start on.
Before you turn off the recording, I'm going to have a quick chat to him.
Yeah. Yep. Okay. Brett wants to just have a chat with you, and I'll just start opening everything up.
Hello, boys and girls. I might as well jump in now. I was planning on now tomorrow night, but I got to do it at Wollongong, and then I might come there on Thursday night. Forksy, has anything been discussed? Is everyone all right for a prac? Did you just want to do any prac work? for the boys and girls at Nowra just before Thursday. Sorry, before next field day. See, some students are happy just to go to the field day. Some feel they need a bit of a refresher. All pretty happy? All right. I might pop in Thursday then, just see everyone, say hello. And then what about Maria? Do you want to have a bit of a refresher? Because I'm going to try and organise Brett Lyman for a day next week if you want to. And I might send out some emails tomorrow, some little messages. So any students from Maria there? Yeah, that's a good idea, Foxy. All right, I'm gonna okay, so the Maria students want to try and get Brett Lyman. I'll get him down there for a night and just go through a few things, just do a bit of a refresher, do like a small, are you doing like a small rise and fall, height of collimation, setting up the dumpy, 2 peak test, just practicing it. The reason why I'm staying here at Wollongong tomorrow night, I was going to pull out the theodolite and throw some right angles. It's actually not part of it, is that right?
No, it's not.
Thanks, Clarissa.
Clarissa.
Yeah, and then just let us know. Now, Wagga and Griffith, I'll let you boys and girls talk to Adrian and Frank, and let you guys organise that. And Johnny's already sorted out Miller. All right. Glenn, do you want me to turn off the recording now? Okay, I'm going to turn off the recording, everyone.